to talk about sequences. A sequence is simply a list of numbers in a specific order. So for example, 5, 7, 9, 11, 13 is a sequence, and it happens to be a finite sequence because we only have 5 numbers in that particular sequence. But here's another sequence: 100, 99, 98, 97, and continue. And I put those 3 dots there, letting you know that it continues forever. And we would consider this to be an infinite sequence. Sometimes we define a sequence as a function whose domain is the set of positive integers, or the set of positive integers up to n. In this case, n would be 5. So for example, if you were just thinking of this as a function, we could say that f of 2 is equal to 99 because the second term is 99, or f of 4 is 97. And of course, we couldn't ask for f of 3.5 because we don't have a term number 3.5. We have term 1, 2, 3, and 4, and so on. But often we don't use this type of notation to represent the terms of a sequence. Often you see it looking like this. Instead of writing f of 2 equals 99, we would say a sub 2 equals 99. And we use subscripts to represent the term number. And a sub 4 equals 97. Similarly up here, I could have said a sub 3 equals 9. And a is very commonly used. I mean, we could use b. I could say b sub 3 equals 9. But a is very, very common. Let's look at another sequence. How about 1/2, 1/4, 1/8, 1/16, 1/32, and I'm representing an infinite sequence. So I could just ask the question, what's the 5th term of the sequence? And we should be able to say that a sub 5 equals, and we look right here, 1/32. Maybe you have a sequence that looks like this: 2, -9, 2, -9, 2, -9, and maybe I'm implying that this sequence is infinite as well. I could ask for the 4th term of this sequence, and you could look at it and see that it's -9. Or the 5th term, we could see that it's 2. And I bet you could consider the 100th term and determine that, hey, all those even term numbers are always -9. And even though you don't see it on the list, you know that it would be -9. And sometimes we represent sequences with a formula. For example, this. Suppose I said a sub n equals 3n squared minus 1. And by the way, sometimes you see people write it more formally with braces around the a sub n. I'm going to be more casual and not write it that way, but you'll sometimes see that. But let's just write a sub n equals 3n squared minus 1. So let's just find a few terms in this sequence. So if we were to find the first term, n is 1, we just substitute 1 into our formula. So we have 3 times 1 squared minus 1. We can do the arithmetic. 3 times 1 minus 1 is 2. Let's find another one. The second term of the sequence is 3 times, now here's our formula right here. that we're using. So now our n value is 2, so we're substituting 2 into the equation. So we have 4 times 3 is 12, minus 1 is 11. And let's do a third term. Now n is equal to 3, so we substitute in a 3 here. So 3 times 3 is 9, times another 3 is 27, minus 1 is 26. But with this kind of formula, I could certainly just jump to the 100th term. We could find the 100th term without a problem. Pop the 100 in for n. 100 squared, what is that, 10,000? So we have 3 times 10,000, that's 30,000 minus 1. So it's 29,999. So this particular sequence, if you were looking at the list, starts with a 2, then there's an 11, next is a 26, and you keep going, and out here at the 100th term is 29,999, but on it would go. Let's look at another sequence. Let's let a sub n equal 7 times negative 1 to the nth power plus 5 times n. And note, we can find any term of this sequence just by substituting in a value. Let's just find the 31st term. So that means n is 31. We substitute in a 31 everywhere we see an n. And then we simplify. So negative 1 to the 31st power, so negative 1 to an odd power means we have negative 1 times 7. And we have 5 times 31 is 155. And we do the arithmetic and we have 148. So for this particular formula, it was not very difficult to find the 31st term. And similarly, we could have found the 83rd term or the 700th term. Let's look at another sequence. I want to look at this sequence represented by this formula. A sub n equals 2n plus 1. So let's find the first 5 terms. 5 terms of the sequence. So I'm looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And let's just make the substitution. That means n is 1, we'll pop in a 1. And then n will be 2, and then n will be 3, and then n will be 4, and last we'll substitute in 5. And if we do the arithmetic, we'll have 2 plus 1, and 4 plus 1, 6 plus 1, 8 plus 1, and 10 plus 1. So there's our sequence. So let's write that as a list. Horizontally, we have 3, 5, 7, 9, 11, and on the sequence goes. But I want to point out this to you. If you look at this particular sequence, it's not very difficult to get from one term to the next. As an alternate way to think about the sequence, notice we could just start with this 3, add 2, add 2, add 2, add 2, and continue that pattern. And that gets us to a different way to represent that sequence. Before I do that, let me talk about the fact that sometimes we represent the nth term, or we always represent the nth term, with a sub n. So out here somewhere in this sequence will be an nth term. The term right before that will be the a sub n minus 1 term. And by the way, the term after it would be the a sub n plus 1 term, because the subscripts are just incrementing by 1. But notice what that means. I've pointed out right here that to get from one term to the next, to the next, to the next, you would add 2, add 2, add 2, add 2. That means out here, when we're at some general a sub n minus 1 term, to get to the next term, we would add 2. So if we start with a sub n minus 1, just any term in the sequence, and we add 2 to it, we'll get the a sub nth term. But you do have to have a starting place when you see a formula here. This says just to get from one term to the next, you would add 2. But for this particular sequence, we would need to say, start with the term, the first term being 3. And this formula right here is a formula that represents the sequence in the same way that this formula does. They're just alternate ways of representing that particular sequence. This first sequence this first formula is called an explicit formula, where you can find the value of a term based on its term number. So I could find the 50th term by putting in 50, or the 100th term by putting in 100. This type of a formula is called a recursive formula, where finding a particular term of the sequence requires that you know the term or terms that precede it. Let's look at some more recursive formulas. Let's let the formula be this. A sub n equals 4 times a sub n minus 1 minus 17. And remember, you do need to be told a first term, otherwise you wouldn't know where to start. And we'll let the first term equal 5. And let's let the directions be, list the first 4 terms of the sequence. So the first term is actually given for us. Now let's find the next 3. So a sub 2 equals, now let's take care with this formula. N is 2. That means this n minus 1 is a 1. In other words, to find the second term, you would take 4 times the previous term and subtract 17. And sometimes when I'm doing problems like this, I'm going to write the formulas for the next few terms, and then I'll come back in and fill in the details. So the third term is 4 times the second term, right? This is the term just before this term. Subtract 17. And the fourth term would be 4 times the third term minus 17. And now I can go fill in the details. So for the second term, I have 4 times 5 minus 17. That's 20 minus 17, and that would equal 3. Let me separate these so we can see them better. The third term is 4 times the second term, which I just found, minus 17. So I have 12 minus 17, and that's negative 5. And again, it's running together a little bit. Let me separate it. And the fourth term is 4 times negative 5 minus 17. And we do the arithmetic there, and we have negative 20 minus 17, and we have negative 37. So we can tell the terms of this sequence are 5, 3, negative 5, negative 37, and on we go. Notice for this recursive formula, because finding the value of a term depends on the one prior to it, if I asked for the 100th term, we couldn't get there directly because we would need the 99th term. And to get the 99th term, we would need the 98th term, and so on. Let's look at another recursive formula. Let's suppose we have a formula that is a sub n equals a sub n minus 1 plus a sub n minus 2. Now this implies that finding a term requires that you know the previous 2 terms. So for this formula, not only do you need a starting place, I'm going to let the first term be 2, but you also need a second term. I'll let the second term be 7. I didn't write the subscript. There we are. So we're going to find the first 4 terms in the sequence, defined by this recursive formula. So the first term was already given to us. The second term was given to us. So here we go. The third term is found by adding the previous 2, the second term plus the first term. And let me come down here and write my formula for the fourth term. Then I'll be ready to go when I get there. It's found by adding the third term plus the second term. So if we come back here, my second term is 7, my first term is 2. I add those together and I get 9. For the fourth term, I add the third term, which is 9, and the second term, which is 7, and I would have 16. So this particular sequence looks like this: 2, 7, 9, 16, and on it goes. And notice, because of this being a fairly simple formula, you could probably write some more terms without too much of a problem. Notice 2 plus 7 is 9. 7 plus 9 is 16. So our next one, even without writing it out formally, we know the fifth term would be the sum of the third and fourth terms, and we would have 25. And we could add these two together and get the next term, and so on. So keep in mind that we've talked about 2 different types of formulas that represent sequences. We've talked about explicit formulas, where the term can be the value of the term can be determined based on the term number. So formulas like this, a sub n equals negative 5 to the nth power, or a sub n equals 3n plus 11, or they could be represented by recursive formulas. Like this, a sub n equals negative 5 times a sub n minus 1, where a sub 1 equals 1, or a sub n equals a sub n minus 1 plus 3, where a sub 1 equals 11. And if you compare these, and you can do that after we turn off this video, you'll see that these two represent the same sequence as do these two. And to finish, let me come back to this idea. Remember that a sequence can be just thought of as a list of numbers. For example, this sequence, 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. This is a list of numbers, and it is a sequence. This happens to be the list of prime numbers. And in fact, there is no known formula for the sequence of prime numbers, but it is still a sequence.